minus 2x minus 3. Hence, give all the factors of the expression when P and Q have these values. All right, so we have our expression here. Okay. X to the power of 4. You want to get it from this time. Plus px cubed. Plus px cubed plus qx minus 81. All right. We have to find the factors, the values of p and q, so that this expression will be divisible by x squared. Okay, so that this will be divisible by x squared minus 2x minus 3. Okay, so x squared minus 2x minus 3, right? So the first thing we can do is we factorize this quadratic equation here, this x squared minus 2x minus 3. All right, let's break it down into its factors. All right, so we're going to get our a. A is the coefficient of x squared, and that is 1. B is the coefficient of x, that is negative 2. All right, and C is our constant, all right, which is negative 3. So as always, you're going to multiply A times C, right? So you say 1 times negative 3, I'm going to get negative 3, right? So now we have to find two numbers that when we multiply them, okay, when we multiply these two numbers, we're supposed to get negative 3, all right? And when we add them, we're supposed to get negative 2. So the two factors of 3 are 1 and 3, right? So if we make 3 negative, all right, 1 times negative 3, we get negative 3. 1 plus negative 3, we get negative 2. So these two factors, they suit the conditions. So we break x squared minus 2x minus 3 into two factors of x plus 1 and x minus 3, right? So, right, to get the values of P and Q, we are going to use the factor theorem to find these coefficients, all right? We're going to use the factor theorem to find these coefficients, all right? So, we're going to first find our critical value first. We'll start with this first factor here, all right? X plus 1 equals 0. Therefore, x equals negative 1. Right? So basically what we're saying is that when we substitute x for negative 1 into this polynomial here, we're supposed to get 0. All right? So we're going to equate f of x to 0. So we're going to say 0 equals, all right? Then we're going to replace x with negative 1, right? So we have negative 1 to the power of 4 plus p negative 1 to the power 3, p times negative 1 to the power 3 plus times negative 1 right, minus 81, all right. Negative 1 to the power 4, that's 1. Negative 1 to the power 3 is negative 1 times p, we get negative p. Q times negative 1, we get negative q, minus 81. All right. Then 1 minus 81, we get negative 80. Okay. So we'll say negative p minus q minus 80. Right. Then we take 80 to the other side. Okay. We take 80 to the other side, and we're going to have negative p minus q. Right. So this will be our equation 1. Right. That will be our equation 1. One minus 81. This one here.
Okay. Sir,
Yes.
excuse me.
I can get you.
So the other way is you can actually regroup them like
I can get you.
you get it. Yes, you get it. One and minus one. Then you leave that minus p minus q.
You're saying you take this one over the equal sign and this 81 over the equal sign. Hello? Are you saying you take this one over here and this negative 81 over the equal sign?
No, the way you subtracted it. Have you just assumed that because they are numbers, usually, right?
These 1 and 81 are like terms, so you can operate with them. But the letters, these are not like terms.
Okay, I guess it's that.
All right, we go to the next factor, which is x minus 3. All right, say x minus 3 equals 0. Therefore, x is going to equal to positive 3. So meaning if we replace x equals 3 into this polynomial here, we must get 0. All right. So we say 0, f of x becomes 0. Oops, just erase that. F of x becomes 0. Okay, and then we're going to say equals. All right, so say 3 to the power 4.
Hello, sir.
Yes, yes.
Can you maybe
That's the factor theorem. The factor theorem states that when you input these critical values into a certain polynomial, in this case it's this polynomial here, you're supposed to get 0. So that shows that these 2x plus 1 and x minus 3 are a factor of this polynomial here. Yes. If we were told there was a remainder, all right, we would have put that remainder here, all right? Okay. Okay, yeah, where was I? I was saying that I think P3 to the power 3 plus Q times 3 minus 81. Okay. Okay, so 3 to the power 4, that is 81. 3 to the power 3 is 27. 27 times P, you get 27P. 3 times Q, we get 3Q. All right, 3 times Q minus 81. Okay. So 81 minus 81, that is 0. Okay, 81 minus 81, that is 0. Okay, so equation 2 will be 27P plus 3Q. Oh, yeah, 27P plus 3Q equals 0. Okay, because when we take this 0, we get here to the left hand side, you still get 0 here. So that is equation 2. Okay, any questions here? Okay, now here we're going to do simultaneous equations, all right? So we're going to say negative P plus Q equals 80. Okay, that is our equation 1. All right, and then we have 27P plus 3Q equals 0, right? So I prefer to use the substitution method here, okay? I prefer to use the substitution method here, okay? So we'll use the substitution method, right? So for the substitution method, we're going to make, let's see, which one? We'll make Q the subject of the formula, all right? In equation 1. We'll make Q the subject of the formula, all right? So it's going to be like this, negative Q equals 80 plus P, all right? So now we have to make this negative positive, all right? So we're going to multiply it by negative 1. We multiply both sides by negative 1, okay? Multiply both sides by negative 1. So put here negative 1 times, all right? Even this side we multiply it by negative 1, all right? So we're going to get -1 times negative q, we get positive q, right? And you say -1 times 80, you get negative 80. -1 times p, you get negative p, right? Then, then we are going to substitute this q equals -80 minus p into equation 2. Are we okay up to there?
Yes.
Yes. As the lecturer says, let's not specialize in confusion. So now we'll replace it. So it will be 27p minus, plus 3 open brackets -80 minus p close brackets equals 0. All right. So 3 times -80, that's -240. 3 times negative p, we get minus 3p. All right. And here we have 27p. All right. Are we clear there? 27.3 plus, right, which is negative 240. Are we clear? Are we clear? So this negative 240, we're going to take it to the other side, okay?
Yes.
Okay, I had a no somewhere that then, where are we not clear? We're using the substitution method for simultaneous equations, okay? This is the substitution method. Yes, so where are we not clear?
This is the substitution.
Yes, where were you not clear? Okay. So we have like terms here, right? We have 27p minus 3p. Yes? We're getting. Okay. All right, wonderful. So 27p minus 3p, we're going to get 24p, all right? We're going to get 24p, all right? And this 240 will be this side. This 240 will be this side, okay? Positive 240. So we say 24p divided by 24 and 240 divided by 24. All right, so p equals 10. P equals 10. Are we clear there?
Yeah.
Okay, let me just recheck because yeah, yes. Okay, but yeah, everything looks correct here. Yes, yes, we're good. Yes, so P equals 10. Any query, any question or queries? Okay, so since we've got P equals 10, okay, since we've got P equals 10, right? Now this P equals 10, all right? We are going to substitute it back into this equation here, all right? Let's substitute it back into this equation here, right? Equation 1, all right? And equation 1. So you're going to have negative 10, all right? Negative 10. Or maybe I should go to the next page. This page is getting too crowded. What do we say, colleagues? I go to the next page, or should I? Because I want you to see all the steps in everything. So maybe I'll go to the next page. We are just substituting P into this equation. Yeah. Yes, so. Okay, so we are substituting P equals 10 into the first equation, which was negative P fatal error. Negative P just hold on, the board wants to act up now. Okay, in the meantime, while we're waiting for the board, calculate for me the value of Q. As well.
Q is negative 90.
Okay, correct. Colleagues, confirm. I hope everyone's finding negative 90. Now I have to transfer this to. Okay. Let's see. Okay, I'm just waiting for the board. Negative P minus negative. Okay, let's see. Wait a minute. Let's see. Let me calculate here on my negative P minus Q equals 80. We said P is 10, so we say negative 10 minus Q equals 80. Oh yes, negative 90. Negative 90. Because you're going to have the negative Q equals 90, then you multiply. Okay, the board is back. So we have negative P minus Q equals 80. Okay, equals 80. I'm not sharing the screen. Okay, sorry about that. Yes, negative P minus Q equals 80. Okay, so negative P equals 10, right? 10 minus Q equals 80. Okay, so say negative q is going to equal to 80 plus 10. Okay, so negative q equals 90. All right, then to make it positive, we multiply by negative 1. Okay, so q equals 90, negative 90. Are we comfortable with those answers, colleagues? If we're not, can tell me, sir, I'm not comfortable, I found a different answer. You share your screen and you show us how you found your answer. All right, it is allowed. It is allowed, right? It is allowed. Or maybe you're saying you don't know that.
Yeah.
Okay. So yes, so P and Q equals 90. So we'll do part 2.